discussing, or rather, we're going to be taking a workshop on LaTeX today. And let's just begin with a quick overview of what LaTeX is, and then we'll move on to actually typing some stuff out. So, LaTeX is text processing document preparation software, much like MS Word, but far superior. If you've seen absolutely any tutorials on LaTeX, you must have read the acronym, what you see is what you get. So this is not that. Microsoft Word or Notepad or any other text editor, whatever you type is what you get in the end as well. But over here, what you see is what you mean, and it compiles completely differently. And this is especially useful if you're writing long documents or documents that may consist of equations or tables or bibliographies, for example. LaTeX will typeset all of that really well. Okay. Rida, I think you will be admitting everyone to the chat room.
Yes, I will be. If Azka, you could share your screen as well so that it's easier for everyone to see.
Absolutely. If there's just, here you go. Can everyone see the screen? Can everyone see the Mac tech on the screen? Okay, that's good. We'll get to this in 1 second. Anyway, so LaTeX is pretty easy to catch on. It does have like the initial learning curve is a bit difficult, but once you've written one document, you're good to go. And it's actually much easier than Word from there on. And honestly, just trust that if there is anything you can't figure out, you will find an answer to that on Tech Stack Exchange. Um, so yeah, I think that's that. And now let's begin with how to actually use LaTeX. So we have two options. Much like with MATLAB, we can either get a software downloaded onto our local machine through MathWorks, or we can use an online editor on MathWorks again, right? Similar to that, you can either download a software, which is what I have open on the screen. I will not ask you to do that right now, but I just wanted you to see it really quickly. And or we can just use an online editor. The advantages and disadvantages of both are as follows. So with an online editor, which is this overleaf over here, you are dependent on the internet. There could be data security issues. You are not sure how all the packages you're loading are working. um, and the advantages are that it's easy to use. You don't really have to download any software, right? And the biggest disadvantage with actually downloading one of these softwares, this MacTech, onto your machine, is that you need a distributor, you need an editor, you need to figure your way around those, all of that. But what I would recommend is that we start with Overleaf, you and I together, and then once you're comfortable typing out documents in LaTeX, you can move on to actually downloading it on your machine. So I used this for one or two articles right in the beginning when I was getting used to LaTeX, and then I moved to this right here, Tech Shop. So, anyways, to download that, I will leave these two links in the comments under. I will leave them somewhere. I'll make sure you get them. Don't worry about that. But it's on tug.org, and you can find a software for Mac and another one for Windows. I haven't used the one for Windows, but for Mac, all you have to do is just download this link. You will get an mpkg file in your downloads. And if you just run that, you'll get another file in your applications. And from there, you want to open Tech Shop. So let me just show you what that looks like. This is what the icon looks like. You want to open that. That's your editor. That's where you're going to be typing everything. And you will have a very, very similar layout over here as well. It's very easy to navigate. So do download it. And alongside Overleaf, practice with your local editor as well. Okay, now let's get to Overleaf really quickly and get the session started. So on Overleaf, when you get here, you just need to make an account. It's absolutely free. You don't need an institution email ID. Just your private email ID should be fine. I do have an institution email ID. That's where I made my account a while ago. So I'm just going to log in with that. It might actually help to have this open on the side with you guys as well. Can someone confirm if they're doing that? Any of the attendees? If you can just open this on the side, it would be very beneficial for you. Okay.
Yeah, I have loaded this website.
Thank you so much. Okay, thank you for speaking up. I hope other people are doing the same. Okay, so when you are here, when you're on this page, you want to open new project. And this is going to give you a bunch of different templates as well that you can use. You can check out theses or academic journals, books. The one that will be most useful for us will probably be thesis or a homework assignment. Yeah, but I am just going to start with a blank project. And you'll see that even a blank project is not going to be blank all the way. So let's just call it LaTeX tutorial. And why have we stopped typing? Okay, what's wrong? Right, we've created that. Gonna load a page for you, and as you can see, they're actually gonna help you out. They're not you're not on a blank page. So this is essentially all you need, and in this you're just gonna fill in some waffle with anything that you need will go in here, and the rest of the layout is already there. But let's actually start with a blank page so we know how to write one on like a tech editor later on in tech shop or whatever tech editor you're using. Okay, so your LaTeX file, let's look at this one thing really quickly. You're going to be using this button to recompile. Every time you've written like 5 6 lines, you want to recompile and see if everything's working fine. You can automate this, so you can just set this on, but that gets very annoying. It starts compiling every 30 seconds. So I'd suggest leave it on off and just do command enter whenever you need to compile and see. Other things that you may need to change are the compiler over here. From PDF LaTeX to, maybe, I'm not sure how people pronounce it, LUA LaTeX maybe. But PDF LaTeX is the most widely used, and this should get you through the beginning stages of your LaTeX journey. So that's fine too. Don't change anything else. We will be downloading some stuff in this section, but I'll get to that when we need it. Okay, so we begin every single LaTeX document with by defining our document class. Okay, and what do we want this document class to be? So inside these curly braces, we want to define which document class we're going to be using. The most popular document classes are article, book, or resume, I guess. Yeah, article, book, and report. Sorry, I knew it was an R word and I was thinking of resume. Okay, article, book, and report. Book and report will enable you to have chapters. Articles is just a simple, like if you're required to write a 15-page case study on something, that would be article. We're going to be going with article today. Other parameters that you can define inside these square brackets are, and there are some default cases for, like, if you've set article as your document class, there's going to be some default cases over here. Like for an article, 10 point is the default size. But maybe you want to define it yourself. You want to define 11 point. That's fine. What else can you define? You can define what kind of a paper size or paper format you want. So a very standard one is A4 paper. These things that I'm defining right now, you'll only need to do these once in your life. And then you're just going to copy paste the stuff I'm downloading right now, or what I'm defining right now. Okay. Like, don't let this bore you. It's important for a first class. Sorry, a first session. Okay. So we've defined the font size, we've defined our paper. What else? We could have one column or two columns. So we could have our entire um, article in two columns, like we see in journals, right? But we don't want that. You would write two column if you wanted that, but we don't want that. The default is one column, so we're happy with that. There are some formula specific parameters you can define over here. So you can define something like FLEQN. This is flush equations to the left. So all of your equations will be they'll be aligned on the left. We don't need to define any of this either. What else can we can have a landscape over here. We can have one side or two side pages. So we can have one side over here. This is default for article, or we can have two side if we've got a book or a report. Again, you're not going to be using that for a while now, but if there is any confusion, just reach back to me after this session, and I can help you out with what one side or two side does. It just aligns your margins in different ways. Um, uh, Finally, we can have other parameters are also specific to books and reports. We're not going to be needing any of those right now. So we will skip forward to what do we do next now? Okay, so now that we've defined our document class, we still haven't started typing anything. Like nothing's going to show up if I compile over here. Oh, absolutely nothing. It's just giving me errors. Ignore that. It's because I don't have a start or an end of my document. Okay, so all I've done right now is just define the document class. The next thing that I want to do is I want to download packages. What kind of packages will I be needing? So I assume that we're going to be using LaTeX for maths, physics papers. So the most popular packages you want to download are 3 packages for maths and 1 for physics. These are the 4 standard ones that will give you all the symbols you're going to need, all the equations, all the theorems you're going to need. And if there's anything missing, you can easily find it on what I mentioned earlier, Tech Stack Exchange. So let's just download the most common ones. We've got AMS Math, we've got, let's define AMS Simple, so just simple package, and AMS theorem with an M. But I've never really used anything out of this one. And this one's quite useful. It's called Just Physics. And it has very useful like vector notations and stuff that you can pull out of here. You won't need to know where which command is coming from, but just know that you absolutely need these 4 packages at least. What else? Obviously, we're going to want to load some graphics. So we will use a package for graphics, which is graphic and an X. And if you were on a tech editor at this moment, so this is important. If you were on your local machine, you would want to define the path where all your graphs are. So you've done some analysis on MATLAB, you've downloaded some, you've screenshot some images, and you've placed them in some folder somewhere on your laptop. You want to define the path for that, and how you do that is it's giving me as the top option already graphics path, and you will just tell them where everything is. So users, and I don't know, Apple desktop, and I think I have it stored in a folder called tech graphs. But for this online editor, we're not going to need this. So we can just comment out this line. So this is something new we're learning right now. We can comment out a line by simply placing a percentage sign before that. Okay, every time someone joins, I lose the, okay, that's fine. That's all right. Anyways, we can comment it out by just putting a percentage sign uh, behind the line. Now this percentage sign just means that LaTeX is not going to compile it. As simple as that. You can use command and backslash to comment it out immediately. You can even download a package to comment stuff out. Very fancy and unnecessary stuff. All you need to know is this percentage sign for now for anything that you don't really want to use, but you want there for information, right? What else can we have? If you were writing in another language, you would want to download Babel or Babel if you prefer that. So from the Tower of Babel, and you will want to define what language you want. So I'm just going to go with English over here, which is also the default setting. So I didn't really need to do this, but I just wanted to show you that you could have English, Spanish, Russian, anything over here. You can even have a primary language English and then another language Russian, right? Just like that. And other packages that we can install are, so we've got all the essential ones. Um, and now I think we will need one for the bibliographies that we're going to have in the end. So for that, the most famous package is BibLaTeX. So I don't think we need to install any of these yet. I think these should be enough for now. Okay. So I think you might have seen the reconnecting that I got for a second over here. That's one of the biggest disadvantages of using Overleaf. But again, not big enough to not start with that. So no worries. Anyways, like I said, these packages are enough for now. When we start typing, if anything else comes up, we will just load that package, come back and load it. Okay. Another thing that you need to define before you start is you need to define your title. So I can have something like the title is beginner friendly latex tutorial. Yeah, let's do that. I will fix this in a second. Okay, beginner friendly latex tutorial is fine. And then you must have seen that in titles, you usually have a large title, and then underneath that, you have a smaller title just to describe what's going on. So in LaTeX, I've shown you, I've talked about one command. So I've talked about one symbol so far. That's the percentage sign to get comments. Another one is to use two backslashes to go to the next line, or anything that you write after this will be on the next line, but I'll write it on the next line myself as well, just so I understand what's going on. And I'm going to put this large over here, and just what can I have under the, let's say, open for all Mustians. Okay, that looks good. So that's my title. This whole thing is my title. The large portion is beginner friendly LaTeX tutorial. And then we have open for all Nustians under that. You'll see that in a second. And another thing that I didn't mention over here is I wrote LaTeX with a backslash. Why is that? I can actually, how about I leave it like this and then I show you how it changes. Okay, so the title, what else do I want? I can have author. Author is Azka. That's enough. And I can have date. And the date, you can define the date yourself, or you can just write today and the system will pick up the date for today. Okay, now we start. We start by beginning our document. And as soon as I press enter, it's also going to give me an end document like that. Everything that you write and everything that you see in your final PDF document, or however you decide to load it, is going to be within these two lines, 18 and 20. So let's just put some space between them. Okay, so let's start visualizing our document. What's the first page? What do we want as the first page? We want the, is someone trying to speak up? Okay, I think that's fine. Um, okay, so we want to visualize what our document's going to look like. And the first thing that we want in our document is probably a title page, right? That's what we've defined behind begin document. And now is we are going to load it. Everything that you type, everything that you see in the document will be within these two, begin document and end document. So you need to load the title that you defined in the, and I'm going to use a fancy word over here. It's actually not fancy. I think this everything behind begin document is the preamble. This is where you download, this is where you define your class. This is where you download packages, and this is where you define title. These are the three things that this preamble does for now. Okay. So begin document, the first thing I want is backslash make title. And whatever I've written over here, it will just pick it up and put it inside my document. So make title, that's my first page. Let's see if we have that. I think the compiling is actually going to take time today. Okay, looks good. We just have one page over here in the right side window, which is where we see what our document's finally going to look like, and we have a nice um, title page over here. So that's good. What else can we have? Let's get to the new page. So when you're actually typing out all your work, you're not going to need to keep defining backslash new page. Okay. But if I started writing right under make title, it would give me text over here. I don't want that. That's why I've especially defined go to the next page. Okay, let's do that. And what do I want on the next page? Again, go back to your mind's eye. What do you want on the next page? You probably want a table of contents. Simply write that down, backslash table of contents. Okay, and I'm going to show you how this changes. It's going to change automatically. You're not going to need to do anything over here. It'll just keep changing. So table of contents, and now I can, maybe I want page numbers for my document, right? So I'm going to set a counter over here. Set counter, and you have for your page, and you can have one over here. So the first page that's going to be numbered something is going to be the page of the table of contents. One more thing, if I leave it like this, it's going to give me a number under the make title page as well. I don't want that. So for the make, so everything before new page is what's happening on the title page. Over here, I can define the page style by saying this page style, and then I have a few options over here. I'm going to use empty to indicate there's three options possible over here. You can either get your page number on the top, you can get it on the bottom, or you can have no page numbers at all. An alternative to this page style is just page style for all your pages. But this is the only page that I'm bothered about. I don't want it to be numbered. So I'm going to leave this one as empty, and the rest can be numbered. They can be anything. Okay. And I don't want the numbering on top. So I'm not bothered about that either. Let's recompile and see if everything's going fine so far. Okay. We've got a second page of contents, and it is indeed numbered. Oh, I wanted to show you something over here. So I've got LaTeX over here, and this is not how LaTeX is actually written. So if you wanted the actual form, you can just put it with a backslash and you will get the correct LaTeX, hopefully. Oh no, you've lost it. What do you want over here? Yeah, I think it wants it with a capital T and a capital X. Yep, so that is LaTeX tutorial. Okay, I am bothered by the fact that there is no space between LaTeX and tutorial. All I need to do is just put a backslash over here. This is an empty space. This should be fine. Yep, so that looks good. Okay, we've got a title page, we've got table of contents. What else do we want? We can just, I think we can now finally start typing 25 minutes into the session. So let's go on to the new page and simply just start with the first section that we would want. In most articles and most reports, the first section is an abstract section, and LaTeX very conveniently has a begin and end section for just that. So you begin an abstract, okay, and it gives you an end abstract itself. That's it. And you need to put in whatever you want over here. So I actually loaded that lorem ipsum thing to copy paste over here. So let's just do that. Okay. Okay, I think that should be good. It doesn't matter that it's indented. Abstracts usually start with an indent. So if you don't want that, let me actually show you first what it looks like. We've got an abstract over here, right? But say I don't want this indent that it's giving me over here. I think it's bothered by, yeah, it was bothered by the indent that was already there, but it wasn't really doing anything. Anyway, so if I don't want this space over here, I can just start with backslash no indent. And me personally, I'm very used to typing this no indent out. I start every paragraph with backslash no indent, and you'll get used to that in time as well. So I've got my abstract. It's neatly placed in the center. I didn't need to do anything. I didn't need to align it or anything like that. So now I'm just going to start with my actual sections. Begin abstract, end abstract, and then every time you want to start a new section, you will just begin not even begin, you will just do section and whatever you want that section to be called. Let's call it introduction, right? And you don't need to end this. This is just a simple section over here. Okay, what can we have over here now? I can just have the same waffle over here and recompile to see that everything looks good. And I also want to recompile to show you that the table of contents are now going to start getting populated. So see, I put in an introduction and now I've got one as my first section along with the page number. Yep, page number 2. That's good. Now, what else can I do with this text? So we're just going to quickly discuss some things that we can vertex over here. If you want to skip to the next line, I think I've already mentioned this, you just use double backslash. And you don't need to take it to the next line. I did that just so it's easy for me to look at, okay? So this is just going to give me a new line over here, yeah. And see, the new paragraph starts with an ugly looking indentation. We're gonna get rid of that. Okay, we don't have that anymore. Other things that will achieve the same the same effect as two backslashes is you can have something like, you can go to the next line. So suppose you want another one. My screen is stuck. Okay, right. So suppose you want another line in between and you want to define how far away the two lines need to be, you can just do that over here. So I've got a V space as in a vertical space between my two lines, between the above and below portion. And I want them to be 5 millimeters apart. So that is just gonna give you that. And again, okay, what else? Similar things can be achieved by, I'm gonna stop typing them out. Similar effect can be achieved by big skip, medium skip, and small skip, right? These are just gonna give you spaces in between your uh, in between your lines. Big skip, as the word suggests, is going to be a bigger space, and small skips just going to be like, it's just going to move you to the next line. That's it. These are things you can experiment with. I haven't mentioned it explicitly, but obviously all the LaTeX commands that I'm using will need a backslash over here. So backslash here, backslash behind medium skip, and backslash behind small skip. So we should be fine with that. Okay, let's start typing some maths now. Okay, let's get another section over here and call it type math. Okay, that is fine. Okay, so there are two main ways to type mathematical equations. Let's call it that. And I only wrote this line in here because I wanted to show you how I can get a further section or a subsection, and it is just called the subsection. Everything on LaTeX is just very, like, the words are very self-explanatory. So just a subsection over here, and I'll show you what that does. Like I said, there's two main types over here, right? There's another thing I can do. I can define those two types over here by actually, so suppose you want to number those two types, or you want them in bullet points. All you want to do then is begin an itemized portion like that. So it gives you the entire layout itself. All of this, it loaded itself. Begin itemize, and then backslash item, backslash next item, backslash next item, and so on, right? And let me show you this, and then I can show you an alternative. So the two types that I'm thinking of are, you can either use dollar signs to get inline equations or symbols, mathematical symbols, or no, I want to start another bullet point now, or use something called an equation environment. Again, that's going to be begin equation, end equation. I'll show you that too. Use equation environment to define an equation separately. Let's not type that out. Let's see what that looks like, the bullet points. I should have said something in here. Okay, so yeah, this is what the bullet points are going to look like. You might want to use enumerate if you want them to be numbered. If you want 1, 2, 3, 4, you can use enumerate over here instead. So like that, but we don't want that. So we're going to skip that. Okay, subsection. So this is, so I'm just going to talk about these two bullet points in the following two subsections, which are going to be 2.1 and 2.2. We can call this mathematical whatever in within line, within text is fine. Okay. And we can begin with something as simple as with the quadratic equation. Okay. And I want to define the quadratic equation over here, but I don't want it on a separate line. I just want it on this line in within the same sentence. What I'm going to use is I'm going to do is I'm going to make use of dollar symbols. Yeah. And over here, I can just start writing y is equal to ax squared plus bx plus c, where a, b, and c are numerical coefficients. Okay, so I wrote that last part to show you that I can also get, let's actually look at this. Let's see what happens. So I've got this nice little italicized equation over here, right? What's happening there? Oh, sorry. Just bx, not b raised to x. Okay, bx plus c, where a, b, and c are numerical coefficients. But to indicate that a, b, and c are also part of the equation, or they're also mathematical symbols, I would recommend that you write it like this. So you write your a, b, and c also in dollar signs. So it's going to be a bit time consuming, but the end result's going to be worth it. Let's see how that looks. Stop forgetting about no indent. Okay. So, right. So we can see that they've also italicized the A, B, and C now, and it looks more like what we see in textbooks, right? So that is something we want. And I think that's about it for this subsection. The more important one, the one that we're going to be using more often, is equations on their own line. So the equation environment, let's talk about that. Okay, let's write the, so let's just continue with the same example, the quadratic equation, and let's write the quadratic formula for that. The quadratic formula is as follows. And now you start writing an equation, and for that you build an equation environment. So you just go begin equation, it gives you an end equation. And over here you define, okay, so because you're in an equation environment already, you're not in a text environment, you no longer need dollar signs. You can just start typing your equation over here simply, and it'll know what to do. So I'm gonna need minus b plus minus b squared minus 4ac, so on and so forth. But for that, if you remember the equation, it has a fraction, right? It has something on top of the fraction, something underneath. So the symbol for that is backslash frac, and then you have two arguments like that. This will be the numerator, this will be the denominator. In the numerator, I want minus b plus minus. How do I get plus minus? Simply backslash pm. So that's your plus minus. Minus b plus minus square root. For square root, you go backslash square root, just that, and it's going to give you curly braces where you're going to pass your argument for that square root. This is simple, b squared minus 4ac, and that's my numerator. And in the denominator, I have 2a. How does that look? Oh, I think it's taking a minute. Right, we have it. Okay, so because we use that begin equation, we were using an equation environment, we also have a label over here, right? We have an equation number. Yeah, so this is going to be automated as well. It's going to increment itself. When you write another equation, it's going to automatically be equation number 2. So this is something you don't need to worry about. And what I did over here, where A, B, and C, yada, 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 we can write something like that over here as well. So just in a line of its own, we don't need to put that in equation. If you did put this inside equation, so over here, you would need to now, so when we wanted to put equations within text, we use dollar signs. If we want to use text within equations, we will use backslash text, and you will write some text over here. That's it. It's not going to make it mathematical. But I can just write that outside the equation entirely, where $a, $b, and C. Oh, I was writing the dollar on its own. Are coefficients of something, something, something. We can skip that. Okay. So that is your first equation in LaTeX, if it is indeed your first equation in LaTeX. By the way, guys, I'm sorry if this is like going really slow. I just wanted it to be perfectly beginner friendly, because when I started with LaTeX, it was very daunting for me. So I'm actually taking my sweet time setting up equations. But let's actually amp things up a little. Let's try slightly more complicated equation. Example would be the modeling equation from Volterra's population growth inside a closed system. If anyone knows about that, I wrote a paper on this a while ago, and these are not fond memories right now. But let's start defining the equation now. Okay, so what do we, which equation, and let's just get rid of the second one. Right, and the equation looks something like this. Okay, so I wanted to use this equation because it has a derivative. And the derivative command that I'm using is coming from the physics package, as it is mentioning over here. And in the derivative command, again, you want to define what you want in the numerator and what you want in the denominator. So I want, let's say, dp by something, and that's going to be, so dp by dt. But I want t tilde. So all I'm gonna do is just get, so I have this t, but I want it in, I want a tilde over it. So I'm just going to get tilde like that and put it inside curly braces. Just make sure all your braces are adding up. Okay, I'm gonna move the cursor down so you can see what's happening. So we've got p in the numerator, t tilde in the denominator, and this is equal to AP minus BP square minus CP, and then there's an integral term. So far it looks like the logistic equation, but we add an integral term because it's inside a closed system. And yeah, this integral term is actually going to lead to all the toxins, and we don't need to go into that. Okay, and now we need to define an integral, and for that we simply use int, and that's coming from the AMS math package. All of the stuff doesn't matter, whatever you're comfortable with. You can even use diff over here, that's another command, but I prefer dv because I've always used that. And I'm sure there's other versions for integral as well. Very easy to look this stuff up. Okay, so for the integral, what do I want inside my integral? I want p of x dt. Okay, no, dx. Yeah, p of x dx. And now I want an upper limit and a lower limit, right? So for, okay, another thing to note over here, whenever you want absolutely anything in the subscript, you make use of underscore over here. And if you want absolutely anything overhead, your symbol or whatever, you are going to use the caret symbol or this one, right? So let's make use of both of them. My lower limit is going to be underscore, let's say starts from 0, and the upper limit is going to be tilde t again. Yeah, t. Yeah, that looks good. We have a bracket missing. I think that is the error. Is someone typing on the board?
Yeah, sorry, mistaken.
It's fine. Okay, that's all right. Okay, what problem do you have right now? Okay, this one. We had an incorrect bracket. Okay, let's see what that looks like. And I think I'm gonna need to edit something. Where A, B, and C are coefficients or something, a slightly more complicated equation. And this is what your equation looks like. I think I want this to be, yeah. Okay, hopefully you guys are able to see what's happening on the screen. So we've got this, and I just want a space between px and dx, and I will do what I did earlier in the session as well. I just put a backslash over here to get some space, and we can see what effect that has after a while. Okay, and over here, what can I define under this equation? with population at initial time defined as, and now I want to use math symbols inside text again. So what do? I just use dollar signs, and I have p of 0 is equal to, and I'm given some coefficient p underscore 0, p naught. Okay, and I can have, yeah, let's just write this down as well. P of tilde t close bracket represents population at time okay. Okay, that looks good. So just for the sake of completeness, your equations are going to look like this. It's going to be an equation followed by something, or you're going to define your parameters. That's also easy to do. You can just start doing where a is equal to this, and then get your backslashes, b is equal to this, and so on. You can do that as well. I hope I have an example lined up somewhere where that happens. But anyway, so far so good. Let's look at, so there's two more examples that I have for mathematical equations, because I thought that they will, just a second. Okay. Okay, let's see. Well, what can we have now? We can, okay, let's do a summation example. And let's do something very simple like sum of first n terms. That's fine, right? Sum of first n terms, what's that? And I can define this inside my equation again. Or let me show you something else we can do. Suppose I don't want and I don't want my equation numbered big for some reason. It's an unimportant equation or whatever. I don't want it to be numbered. I can just use begin equation star. And that is not going to number my equation. And the next equation will start from 3. This one's not going to be numbered. So let's just do something simple like Sn is equal to backslash sum. And just as simple as that, your summation sign is just backslash sum. That's it. And I just mentioned earlier that if you want anything under your symbol, you want to use underscore. And I'm going to put k equal to 1 over here. K as my argument, k equal to 1 and goes to n, starts from 1, goes to n, and the actual argument is just k. And I can have 2 equal to signs in the same line as well. That's not a problem for me. And now I can define the actual equation, which is, and then 2 arguments again. What is it? N into n plus 1 and 2. Yeah. Let's see what that looks like. Okay. Sum of first n terms is this. All right. So that is one example. You can, I've already mentioned this. If the space between the two lines bothers you, all you need to do is just put a big skip between them, backslash big skip, or just backslash v space and whatever size space you want between them. But I think in theory, this is gonna look better. It's not going to be such chunky equations, right? So it'll be fine. Let's look at a complicated summation example, and then we will move to something else. One more mathematical symbol, and then we'll be done. More complex summation example, let's say, is as follows. And let's do begin equation again. And now do, okay, what can we use over here? We can have, actually, oh, I actually got this one example off the internet because it was using vectors. So you might come across this one. I just wanted to show you what vectors would look like in Latex. So we've got vector X and vector Y as my two. I don't need this, but I do need one over here. Yeah, and let's just close that as well. And this is equal to, the problem it's having is that I needed to close with a round bracket. Okay. And this is equal to, I can keep defining it on the same line, but just for visual clarity, I'm going to move to the next line and we can have summation. And now over here, okay, so the argument of the summation itself is f of z and subscript x, y. Okay, that's the actual argument. But I want several things in the, I want several parameters in the subscript of the summation. So I'm going to do that over here. And I'm going to make use of another command called substack to stack those 2, 3 on top of each other. So for example, in this one, I just had k equals 1. If I wanted something else under it, like k equals 1 and k can't be equal to 4, not equal to 4, I would need to stack them on top of each other. So just as the word suggests, I will be using this. I will be using backslash substack, and we can start defining. Honestly, always use your own examples so you know what's actually happening in them. Okay, and we have vector. Let me just show you two. X, Y. I'm definitely gonna lose count of how many brackets I have over here. Yeah. Okay, so that's one. I don't want to close bracket right now. That's one, and another one I can have is, let's say, just that for all symbol that we have, for all x in and let's end that over there. Let's not use anymore. I think this should work. Just do. Okay, these things should go under my summation, and they're not going under my summation because my sum is right here. Yeah, that's it. Yes. Okay, so I hope you saw what happened there. This backslash sum moved down somehow. I wasn't paying attention. So this is my left-hand side, and this is my right-hand side from lines 89 to 91. This is my actual argument, and in Substack, I just have the things that I wanted under my summation sign, right? We can't really see what that is, and I am not sure what this equation represents, so I'm not even going to try and make an attempt at that. But that's basically something. And one more, just I have been saying this for a while, but one more example. Um, let's call it that, so we can't go back on our word. So one final example can be, and I just wanted to show you what an under brace would look like, or even an over brace. And let me just show you that. So we can have a begin equation environment again. Let's not label this one either. And just get something like s to the bar n is equal to s to the bar, and I want n minus 2 over here. This is actually not bar, this is defining the index of s. And then, okay, now I want to write something over here, and then I actually want to type some text under just this bit of the equation. So let me first write the equation itself. It's going to look something like that, and we have delta t 3 over here, n minus 2 again, plus 4 times u and n minus 1, let's say. Yeah, and just one more term over here, un. I think that is complete. Yeah, just need to close that up. Okay, so this is what my equation is. Let's see what that looks like first. Okay, that's my equation. There's something wrong over here. Let me fix that in a second. This is what's wrong. Yeah. And another error has thrown up. Okay, it's very difficult to balance brackets over here because of the because of nothing. Okay, so for the second term over here, if I want to just comment something under the equation over here, I can use something called underbase. And underbase is now a new command, and I will need, and it uses two arguments as well. Like fraction uses numerator and denominator. Underbase uses with backslash always. Underbase uses whatever your equation is as the first argument, and whatever you want under the equation with an underscore as the second argument. And over here you can have some text. And because I need to type out some text, I will need to use the text environment inside my equation. So what can I write over here? This I'm trying to use the big O notation. If I just used big O, that would be, if I just used a capital O, that would be fine as well, but this is more authentic. This is going to give you that slight, like the line going through the O. So we can have that using this. And right here is fine. Delta D squared errors or something. Yeah. Okay. The third bracket was missing. Okay, let's see what that looks like. Okay. We have what we expected, -1 bracket, which should be here. Okay, so big O of delta T square errors is what we have for this term over here. So this is something neat and useful. I sneaked this example into the tutorial to just show you some advantages of LaTeX over MS Word. Okay, so let's move forward from that and quickly look at some more things. We want to look at aligned equations now, and then we'll move on to matrices and graphs and tables, and that will be the end. So I think we're all set up. Let's just quickly look at some more things. Okay, I've already shown you subsection, and I can even have subsection because I'm still inside the math. I'm still talking about math equations, so I can have something like align equations over here. And so equations can be written in, let's not waste time on that. And let's just quickly start with again. And over here, you can use two things. If you want to write equations on top of each other in the same environment, you can either make use of an align environment like this one, or you can make use of something called equation array like that. Okay. So just that. Let me just write the same equation in both of them. Let's keep using the quadratic equation thing. 4ac is greater than 0. And then add some text over here. Rida, any idea why I keep losing my cursor? Okay, and I want to go to the next line, so I'm just going to use 2 backslashes and write that again. Let me just copy that, the whole thing. I don't have to waste time on typing, and then go down and just replace these over here, equal to, less than, repeated over here. And what are these? Imaginary. Okay, and I don't need 2 backslashes after the last one. And let me just copy this into the next one as well, so you can see how the two differ in the aligned environment and otherwise. Okay. Okay, so that's what the two look like. The align environment is far better because it is made for this kind of stuff, and I've aligned it over the equal. It's lucky that the equations are all the same size. But if I had an extra term over here and I still wanted these symbols to align, I could just put an ampersand behind all of them to align them. It's not going to do anything in this particular example because they're already aligned. What these two ampersands are doing are just aligning my text over here. If I added a third one over here, right now it's aligning all the text to the right side of the page, right? If I add a third one, it's going to compile it to the left side of the page. Let's see if that is indeed what happens. Yeah. Okay. And so this equation array, I just wanted to show you that I'm not a big fan, but if you must use it and you want space in between, you can use something like \quad, and you probably want that behind the ampersand. \quad. And that will give you some space in between. So this \quad is useful in general as well if you want space between your in between any two words. And if you just do double Q over here, it will give you double of that space. And you can read up on what the exact measurement is, but I can't imagine why we would need that. Okay, to clear up the space a little bit, let's clean this one out and start talking about something else. So I had some Maxwell's equations over here as well, but I think we should be rushing through the rest. I don't think I managed the time all too well. Okay, and let's just move on to the next subsection and call it matrices. Stuff we will probably need. I actually want to move on to graphics really quickly because we will need to do, and let me just show you that the contents are getting populated on their own and they look quite nice over here. Okay, let's move down to where we were. Okay, matrices. Let's think of a very simple example. What do we want? Okay, an example of a matrix. Again, a matrix, we want to define it inside an equation, right? Let's do that. And we want to use a specific matrix environment as well. So let's use \begin and B matrix for now. Okay, let me start with just matrix and I'll show you all the different options that we have. \begin matrix. Okay, so for this one, I am just going to define a simple 2 by 2 matrix. Let's have alpha. I want the symbol alpha, so I'm using \. If I just wanted the word alpha, I would skip the \. Alpha, and now I want to, so I'm on the first row right now. I want to move on to the second element. Whenever you want to move on to the second element, whether that's here in a matrix environment or in a tabular environment, you will need to make use of ampersand to move to the next element or the next cell. And we can have beta over here. And now I'm done with the first row and I want to skip to the second row. I can have gamma over here, second row, second column, and just delta. That looks good. Yeah. Let's see what that gives us. Okay, that's a simple matrix with no brackets, no nothing on the left hand side. It's not even technically an equation. So let me just write all the other options that you can use. I won't show you, just to save some time. A B matrix will give you square matrix, capital B matrix will give you parentheses. A B matrix will give you, I think this was straight lines. Yeah, let's actually just have a look at this. So just if you wanted to find the determinant of a matrix. Yeah, okay. And a capital V matrix gives you double lines. These are things you can experiment with on your own time. And a small matrix can give you a matrix within a line. So within, so I can have a matrix defined over here, just in front of the n. So that's basically all the options that you have. There is one more matrix I want to show you, because usually when you're going to be typing maths out, you're not going to be using matrices like this one with actual elements defined. It's probably going to be ABC ... A11, A2, A1, 2, dot, 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 A1, N, something like that, right? So let's look at one that incorporates that. Okay, and let me actually define an equation this time. Let me say A is equal to, and then begin a matrix. And let's do B matrix. That's the one with simple square brackets. And over here, I can have A1 and now I can just, let's not type out too many elements. Now I just want dots in between, right? So I'm gonna do just that, backslash dots. That's my second element. And the third element is gonna be AN, right? I want to skip to the next line. The next line also, I want it to be all dots. So I'm gonna use three dots over here. These are going to be vertical dots between the element in my first row and the element in my last row. You'll see how that looks in a second. And then I want some diagonal dots in the middle. So just T dots. And finally, I can have some more vertical dots and move to the next line. So this is actually a work around it. They aren't technically the second row, they're all the rows in the middle, but this is how you're seeing it. That's why you're typing it out like that. And now you can have just the final row like that, B1, and some horizontal dots in the middle, which are just dots, and the final term, which can be this. And we don't need another double backslash because we're done with the equation. Let's just compile that and see what happens. Okay, so this is more like an equation that you might be using, right? Okay, there's that. And there's stuff you can do with it. Again, I'm skipping some stuff. I have this entire, by the way, I have this, if anyone wants to leave or if they can't sit through the entire session, I've got this entire template with me. So I can just send it to you after the session and you can use all the examples that I have in there. And if anything is still unclear after the session, you can just drop me a message on whichever page you came across the ad for this workshop. So it's not a problem. I'm mostly saying that for myself, so I don't rush through the rest of the session. But if anyone wants to leave, they can, and I can just forward the template to you later on. It won't be a problem. Okay. Let's move on to tables really quickly. We'll look at just one quick table, and then actually let's look at graphs. Yeah, I think graphs might be more useful. So let's have a subsection and just call it graphs. Call it capital graphs. Okay, so what do we want to do with graphs? The tricky thing over here is not tricky at all, just slightly different. I told you that if we were inside our tech editor on our in a software on our machine, we would need to define a path, and then you can just load pictures from there, like whatever the image is labeled, you can just load that and you'll be fine. But if you're on Overleaf, you will need to upload the pictures. So I know which ones I'm going to be using. Let me just see where they are. Where did I place them? Right here. And these are the ones I want. Let's see. I want explicit Euler kappa. And it has already loaded that. Let's get another one over here. And this one. This is explicit Euler, keeping the time step constant. Yeah. Okay, and now I've got all the images that I will be needing for this tutorial. You can just download all the ones that you will be needing. Other stuff that you can download here, let me just mention that really quickly. If you Google something like, I want a nice template for a resume, and that template was using a class that is not defined over here in the beginning. So we have article, book, report, and we have some standard classes in LaTeX. But this one's using something custom made. So for example, for my university, when we were working on our thesis, they gave us a special customized class called Okian Thesis, right? And we used just that. So for that, they gave us a class to download over here. So that's also very straightforward. You just upload, you pick up that file, and you have got it in your environment, and you can start using it. Similarly, for packages, if there are any custom made packages, you can just upload them over here and overleave, right? The classes will have an extension of .cls, and the packages will have an extension of .sty. Nothing you can't find on the internet, not complicated at all. So let's just quickly see what a graph would look like. Can someone please tell me if because I have not been looking at the session at all. Can someone confirm if the session is running and if everything's fine? Rida, if you're still here.
Yes, it is running and it's fine.
Okay, thank you
Yes,
so
it's
much.
fine.
Thank you, thank you. Okay, so okay, we are going to talk about for the explicit Euler scheme, something, and let's start actually defining our image. How do we load our image? So this time we're going to use a figure environment. We've got begin and we've got figure. Okay, and it's given me everything on its own. That's very neat and useful. Include graphics, and over here I want to define the size. Again, this is something you can play with, but I always just use line width. And over here I want to that I want to actually name the image that I'm using. So let's say I'm using this one, explicit Euler, where I'm keeping u naught constant. Okay, and it's also telling me what I can call what the caption can be. Let's say we're being again, I'm not in an equation mode, so I'll need dollar signs if I need to pass any mathematical symbols. U naught and yeah, that should be fine, equal to 1. Yeah, this should be okay. This should work. Okay, and I can label my figure something. Why do I want to label it something? If I want to refer to it somewhere else in the text, and I'll show you how we can do that. But let's just label it this for now. I think this should work, and end figure. Let's also pass something this over here. Okay, let's see what happens. I think we should move on to the next page. Hopefully. Oh dear God. Okay, give it a second. Let me see what's wrong. Have we got the correct one? Should be fine. We've loaded graphics. We've got the correct package over here, the correct image. It because we're in PDF LaTeX, JPG should be fine. It should work. Let's leave this as something simple to minimize the chances of error. Okay. I think it might just be this. Hopefully. No. Okay, let me have a think about this really quickly. I have this on my tech editor. That's where I wrote everything down. Maybe I can just copy it from there. Where did I load the graphics? Okay, I've got both of them here. If this doesn't work, then something's wrong with the underlying settings. Yeah, that works. Okay. I think it's pretty much the same thing that I was typing. Maybe I had incorrect brackets here or something. But anyways, so it is the same thing. We've got our begin figure, we've centered our image, we've included graphics, we've defined the width. You can define this manually. Inside curly braces, this is where the main thing happens. You type down the name of the image that you just loaded. You caption it something, whatever. It's going to number it automatically, figure 1, and we should have figure 2 over here. That's nice. You can get them side by side as well. There's a neat little code for that. And I have that in the template for to give to you later. And you end figure, and you start another figure, and you do exactly the same thing with that. And I've got labels over here, so I can refer to them later in the equation. This all looks fine. I'm sorry, I'm not sure what happened there for a second. Okay, must be a case of incorrect brackets. I think I didn't have square brackets over here. Anyways, and let's quickly try to refer to these equations as well, as you can see in figure. Okay, and now I want to refer to a figure, so I'm gonna, and I want my my reference to be in round brackets. So I'm going to add these. This is not necessary for the syntax. I did that for clarity. And now I'm going to use \ref. And this is what I'm going to use whether I'm referring to a graph or I'm referring to an equation. I can show you how you can make use of an equation as well. And over here, you just do figure, and it's already giving me some options, and it's calling it cross-referencing. Let's do that. And something. Okay. So I have got that over here, as you can see in figure 1, and that's it. And because you haven't hard coded this, like if you, the advantage of this is you could have just written 1 over here, but the advantage of this is that if you go back and add another graph to your article, to your paper, you will not need to come back here and change the number. It will do that automatically. So if I add a graph over here, it will automatically call it 1, this one 2, this one 3, and consequently this over here will change to a 2. So that's a neat little advantage of referring to a figure or an equation. If you were referring to an equation, you would just need to replace this fig with EQ. We don't have any of those in our document yet. That's why it didn't give me any options. But all you need to do is go in front of any of your equations, like over here, and just label it. Label it anything, right? Just like that. This should be fine. And then you can refer to it. As simple as that. Okay, so I think I was a bit worried about going through graphs. So we've done that, and we can now go back to tables, and we can make that the last thing, if that's okay with anyone. If it isn't, speak up. Hopefully everything's going all right. I think I'll find that out after the session. I have no visibility on what's going on. Okay, begin. No, why are we calling it? It's not an environment. It's just a section. So just subsection should be fine. Okay, so we've got a subsection over here before graphs for tables. It should show up on this page somewhere. Okay, and for tables, again, there's an environment defined in LaTeX. I want it to be centered, so I will start with center. Let's actually add this towards the end. Let's just start with a table, a very simple table. And for that, you're going to use a tabular environment, just that. Okay, again, you can see they've given me a layout by themselves. I didn't really have to do anything, but let me just explain what's happened over here. I've got a table environment. These I told you already, for matrices and for tables, ampersands are used to just go from one element to the other one, right? Like here, this was the row 1, column 1, row 1, column 2, and so on. This is going to do exactly that. The only additional thing that you're going to do here, additional from what we did for matrices earlier, is you need to define these parameters. So this is just telling me how many columns I'm going to have. And if they're separated by, so I can just not have this vertical line over here, and they won't be separated by anything. There'll just be some space between them. But I want this line so that it actually looks like a table. And let's actually add a third column as well. And the double backslash is, we've discussed this a few times now, just to move to the next line. That's it. Okay, let's do R1C1, R1C2, and let's have a third one, R1C3. And let me just copy this and copy it one more time and just fix these R2, R3, R3, and R2, R3, and get rid of these double backslashes over here because I'm not moving to a new line after that. Okay, let's see what that looks like. I think we should have some text in the middle. Maybe I should go back and copy that lorem ipsum thing. So this is what a table would look like, right? What else could you want in a table? Maybe you want a line in between all of these, right? Or maybe you want a line on top and on the bottom. All you need to pass is just a backslash each line. So here and here, just that. Please get the correct indentation yourself. Okay. And we will, because we're defining something else now, we will need two backslashes again. Okay, yeah, that should work. And now we have something that resembles a table that we're used to. So just that. And if I wanted, like I started with this in the beginning, but if I wanted it to be centered, all I need to do is just begin and center. I did that for my graphics as well. It's gone red because I don't have an end. I will add that right now. Okay. It's just gonna center it neatly. And that's it. That's what a table would look like. You can do a lot of things with the table over here. So I can add, it's like literally you can see everything you can do. If I want lines on either side of my columns, I'll just put lines over here. That's it. And this will give me lines on either side. If I want a single row over here without any spaces, just like right over here, then all I will need to do is add something called a multi-column. Let's do that. Multi-column is, yeah, it's in the base command, so we don't need to load any packages for that. For multi-row, we would need to. Let me see if we have time for that, and I'll show you really quickly. And for this one, I just want to, so I want my column to span all three, I want my row to span all three columns, right? So I'm just gonna pass a 3 over here. I want it to look like this. So I don't like, so in this row that's gonna appear over here in a second, I don't want any columns. I want a single column. And in the end, I can just call it something like the table name, just that, right? And move to the next line and maybe add another horizontal line the way they have in tables, right? Let's see if that works. Yeah, okay. So we have manually added a fourth row, but we've eliminated any columns from it, and that ended up giving it the look of a table, like the title of the table, just that. And you can do something similar with multi-row as well. Let me show you. Let me add multi-row right here after column 3. Where do I want to add it? Then let's just define a new one, a new table. Look at it in that. Get rid of this multi-column. We don't want the table name anymore. Let's see. And I want another line over here. You'll see in a second why. Over here, I can start by defining multi-row, and it doesn't have that right now, so it's asking me to load that package, but I'll go back and do that in a second. And I want all three over here. I need to pass some size over here. You have very good documentation available for that, and then I can move these to this line over here. Yeah. Yeah, this should be fine. This should work, but it's not going to work because I don't have multi-row. Neither do I have whatever is the package that's using the package that I need to actually load these. So let's just go back and load another package over here. Package and multi-row, yes, and use another package packet to yeah. So this one's just for aligning. It's just to align our table, nothing else. Nothing too tricky over here. And I hope this works. Anything that I'm doing on the fly, I'm a bit worried about. Compiling. Okay. All right. What has gone wrong over here? We just need to call it something else. Let's call it column 1. Call this column 2. And this column 3, so we know what's actually happening. And over here, I did not want this. Obviously, I've got just one. I've compressed these into one, so I wouldn't want this third element anymore, right? And I can, yeah, this is fine. This is just a name I passed. It can be anything, right? And I wouldn't want this either. Okay. Yeah, no, it should be fine. It isn't. This is my first element. I'm treating it as my first element, so I need to separate it with an ampersand. That should be fine now. Yeah, so this is what I've done to get rid of a row. Okay, so as you can see, it takes quite a while to debug an issue in LaTeX. A while ago when I was working on quite some while ago when I was working on my dissertation, a class fellow of mine actually came up with this. So he told us that it takes on average, and it turned out to be absolutely correct. It takes on average 1 day, one entire day, to type out just 4 pages in LaTeX. So it is a bit time consuming, but you can see that it gives us very nice, neat and nice results. So I think it's worth it. And it's been a while since I've used LaTeX, but if you do what I've done right now, uh, 2-3 times over, you're going to be perfectly proficient, and you're not going to need so much time going back to Google and looking up solutions or looking up which package works or which one doesn't and so on, right? So it won't really be a problem. I hope no one's getting like scared of LaTeX from this session. I hope everything. I hope everything's making sense so far. So let's just end with the bibliography over here, right? Yeah, let's use this. So we've already loaded the package that we need. This should be fine. The bibliography, yeah. And yeah, and over here, so they've given you the layout once again. You've got begin, you've got end, and inside over here, you just start defining whatever pages whatever articles or research papers you've used to uh, write your thesis or your paper or whatever. I can call it whatever. I'll tell you that in a second. You don't need to define other parentheses. So over here, I'm just going to write the name of whatever paper I was using. So I copied this from a paper that I wrote a while ago, the same one about population growth in a closed system. So I'm just going to use that, population growth in a closed system. It was from so and so journal. It was this volume, and yeah, published in, wow, 1983. Why don't we have new stuff? Okay, so I have written down this. Obviously, you're just going to copy from the internet. You're not going to type this out. You're going to copy it the way the author intends for it to be copied. And over here, after the bib item is where you want to call it something, to refer to it somewhere else. So I just called it small over here. And then I can refer to it anywhere. So you can, so as you can see in figure, blah, 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 and in paper, and then I will just / cite small, and that's it. That should work, yeah. And that will, and you can just keep on adding over here to your bibliography, and let's see what that looks like in total. Okay, yeah, and you've got references over here. And if you refer to it anywhere, they're just going to load this number from the left hand side. That's it. And we have got table of contents perfectly. Oh, we should have references over here. I'll look into why that's not why it's not here already. But yeah, I think that's what a LaTeX project would look like. Let me show you one that I wrote on my editor. Let's see if I can. Yeah. Okay, this one, and it's already, so I typed it all out. You can see it looks very similar to what we've been doing on Overleaf over here. I've defined a document class. I've defined the packages that I'll be using. Um, okay, we're just at the end. So if someone was trying to speak up, just give me 2 minutes. Okay, I've defined the title, begin document, make title, so on and so forth. I've got an abstract introduction. I've got some equations, some graphs, no tables, no matrices, and then I've got a bibliography in the end as well to close it out. And once I've got all of that, similar to the compile that we have on Overleaf, we have a typeset over here. And this is what my document looks like. So I've got all of these contents, abstract, introduction, model, some equations, non-dimensionalization, analytical methods. Let's see what graphs look like over here. This is that equation that I really wanted to get. Oh, this is, I don't know why I didn't add this. This is very simple to get. It's just a / implies, and I quite enjoyed using it. So there's that. I think another thing I didn't mention was, they're all easy to find out. Like this one is just a / wide hat, and you can pass whatever you want inside it. Uh, / delta. I think we discussed all of these. There's one more thing. I think / NEQ would be not equal to, / LEQ would be less than or equal to, and so on. Again, easy to figure out from anywhere else. These are all my figures. I had some trouble adjusting them with the text. It's nothing that would take too long. And there's that. So I just wanted to show you this in the end. And this did, like, it did take 4 pages per day. And so that's after you've done all the work, after you've done all the maths. It does take a bit of time to type it all out, but it's still quite useful to view it in this format rather than doing it on MS Word or something. So, okay, I think I will stop talking now. It's been an hour. It's been over an hour. I'm really sorry about that. And like I said, I've got the template. I am going to send you these links later on, but I would suggest that you stick to Overleaf. What else? Anything else that you need, just let me know. Just leave me a message and I will forward some useful links for anything that you need more elaboration on. So is there anything anyone wants to say at this point? Any questions? Do we still have a host with us?
Yes. Thank you so much, Azka. There's one question in the chat box. If we could actually do graphs in LaTeX.
I'm sorry, what's that? So make a graph on LaTeX. Rida, I
Assalamu
can't.
alaikum.
Walaikum assalam.
Walaikum assalam. You have a question?
It was actually my question that I wanted to ask that you have inserted a figure in latex. Can we draw graphs or?
No, I don't think so. No, no, no. So what kind of a graph are you thinking of?
Uh, any kind.
Sorry?
I mean, any graph.
No,
So
obviously. So if I want just this graph that I took a screenshot of from MATLAB, I can't find that on LaTeX. But if you want, there's a okay. So a simple example would be you can load images onto your LaTeX. You can use a package called emoji and load all kinds of emojis that you would want. For that, you would need to change your compiler over here. You would need to use LUA LaTeX. For the one that I'm talking about, use package emoji. But you would have similar ones for other images as well. But those will be standard images, like they won't be images specific to your work. For your work, you will need to upload them into your environment over here. And I've already said this, but if you're using tech editor, you will just need to define the path like this, graphics path.
Okay, thank you. One more question. Is this all video recorded on YouTube, I think?
Rida?
Yes, it's been recorded and it's available on YouTube.
Okay, thank you.
Great. If there are no other questions, then we'll be wrapping the session. Thank you everyone for joining us. Thank you, Azka, for such a detailed beginner tutorial for LaTeX. And thank you all for joining us today. We'll be ending the session. Thank you so much.
Thank you. Allah Hafiz.
Hafiz.